Hi guys, welcome to the GPU Fault Finding Guide Part 2. I hope you watched Part 1 originally because this is meant as a sequence of tests that you make to find which part or which area of the graphics card or the circuitry has the fault in it. If you skipped all the tests in Part 1, there's not a lot of point, guys. Do this step by step. So test in Part 1 first, yeah? Okay, so we've done that Part 2. In this part, we're going to look at the various voltage rails, the supply voltages we find on the GPU, where those voltages are derived from, and the sort of resistance readings we should get if we're testing these voltage rails on good graphics cards and on bad graphics cards. The next part, Part 3, will actually go further into the same topic. So just a quick heads up, in Part 3, we will then have a look at the types of short circuits you may find, where those short circuits are and what that means in regards of the chances of repairing the graphics card. Okay, so sit down, 30 minutes or so. Hope you enjoy this part, and then we'll continue down the same vein in Part 3. I've removed all the screws so we can take a look. This one, yeah, it's quite grubby. You can see in there quite a bit of corrosion, especially on the veins of this. Okay, the heatsink compound is very dry. Yeah, it's very dry. That's something that should make you suspect, if you can't find anything else wrong, there's a problem with the GPU. There's quite a bit of dirt and mess on this, so we'll try and clean that off. Just disconnect the fan. Okay, let's just try and clean some of this off if we can. I think it's just dry dust rather than anything else. Okay. And again, visual inspection. So the obvious thing on this one straight away is this kind of like oily looking deposit around the RAM chips. If you see this, the chances are that the graphics card has been used on a mining rig and run for a very long time, or it's been overclocked. And you get this, it comes from the pads of the actual heatsink. So these are the pads that effectively fit on the chips, and they release a kind of, well, it looks oily but it's dry, but it looks oily, and that's what we often see. If you see this, then that's a good indication that this has been running hard. So again, if you can't find anything else wrong, RAM is a suspicion, a faulty RAM chip. Other than that, we can see the GPU. Now, something you'll often find again is people have put them in the oven, or they've been like heating it up with a hot air, reflowing it supposedly, but not enough to melt the solder. And if that has happened, what you'll usually find is like this green area around here is bubbled. Yeah, it's not flat, you can see it's bubbled, broken away, lifted up a little bit, like domed areas. And if you see that, then you can say, really without any doubt, you've got a duff GPU. Killed by hot air, yeah. Normally, if they fail on their own, they don't fail in that sort of way, not the bubbling. Let's have a quick look around the rest of it. So, again, I'm just looking for any visual damage. I don't expect to find broken components this side unless someone's been seriously messing with this. It's more likely to find burnt components. Okay, let's have a quick look around. We'll look at the various sections of this board a little bit later. In fact, not very much later. Okay. Again, I don't think anything's missing here. It looks a bit corroded and messy. Just try a bit of ISO on that. But I think this is just literally embedded grime and dust which has been drawn in by the fans. And this sort of dust wouldn't generally cause a card to fail. Exceptions to everything, of course, guys. Yeah, it's cleaned up a little bit now. You can see that sort of corrosion we were talking about. Let's look around this side. Again, this is the same sort of like dirt on the board really, down here. Okay. So nothing obvious, we can just say a bit corroded. Here's the other one. Just yeah, get the heatsink off. Again, similar sort of corrosion in here. Yeah, just got that off, okay. Now this one, some of the pads have stayed on the RAM chip, some have stayed on the board. It's probably better to put them all in the same place, so I'll try and lift these without damaging them. Just peel them off. Okay, and you can see like a little mark where they came from off the heatsink. So put this one over here. Again, that one can go over here. And then they're safe, okay? Once again, this is very, very dry. So with this one again, if we can't find anything else wrong, could well be the GPU is overheated. But you won't normally, as I mentioned, see any physical evidence of that. So again, this green substrate is flat, it's not bubbled or bulged, okay. That looks all right, really. The RAM on this, again, we get this kind of oily deposit. I'm not saying that's a bad thing, it's just a good indication it's been working hard. Okay, these are around here again, so these are much the same as each other, really. Yeah. This one a little bit less corroded than the other one. Okay, so once again, nothing obvious to see, just the observations I've already made. While we're at this, let's have a look at the last graphics card. Okay, so here's the other card. I've just taken the heatsink off this one. It doesn't have the same sort of amount of corrosion as those cards had. There's a little bit though, I mean it is like around here in particular, you can see it. So there is some corrosion on it. These two areas here are actually a couple of like pads which are stuck on here. I just take them off there and put them there. So these are not RAM chips, these are like dummy spaces if you like. You can see you've got 8 RAM chips here, so these are effectively just spacers to help the heatsink sit flat and level when you bolt it on. The heatsink compound on this actually, yeah, it comes off on my finger. So this does have heatsink compound on. And what can we see? Well, we have a little bit of the same effect around the RAM chips, not so noticeable as that other one. In fact, both those other ones were. Okay. We have another heatsink here and here, so there are some devices underneath. We can have a look at those as well. And I'll just check for any damage on this side. Let's see, so GPU substrate, nice and flat. Okay. If you'd like to see one that has been damaged by hot air and an attempted repair, here is one. Can you see what I'm trying to say now about the bulged areas on the substrate? Yeah, so if you see anything like this, then you have a dead GPU, and to be honest, it's been killed with a hot air gun. It's been overheated. They won't fail this way. Somebody wants to say yes, they will. Comments below, but in my experience, anything like this is actual damage by a botched repair attempt. Okay, so that's the sort of thing to look out for. Okay, so I've removed the other heat sinks as well from this one, so we can have a look around. Let's take some more resistance measurements. But in order to make any sense out of the resistance measurements, we need to understand what voltage rails we're going to find on a graphics card. The important thing we need to understand is that the GPU on the graphics card, the memory, and a lot of the other circuitry doesn't actually run from the 12 volts and 3.3 volts we know we have coming in. We've checked those voltage rails, the resistance on the PCI connector, on the 6-way or 8-way connectors on the graphics card. So we know we have those voltages coming in, 12 volts and 3.3. But the main components of any graphics card, and this is relevant to any graphics card really, is we have the GPU core. This is the actual processor that's doing all the calculations that are required to generate the graphics. Okay, the GPU core requires RAM, video RAM, the core also has to speak to the PCIe connector. PCIe, this is often abbreviated to PEX, which is short for PCI Express. Okay, so you'll often come across that PEX, it means this interface. The GPU core also needs to send video to your monitor, whether it's on HDMI or some other connector. So it has the video out. We'll put HDMI, but it could be something else, DisplayPort, whatever. It could be several things. What else does the GPU need to talk to? Well, it needs to talk to the BIOS. The BIOS contains the basic information about the graphics card. So when you first switch the computer on, the computer through this PEX interface will say to the GPU, what are you? And the GPU, because it doesn't have any built-in non-volatile memory, reads the BIOS and says, oh, I'm one of these, and that's how the thing gets talking to each other. Okay, depending on the GPU, it may talk directly to the RAM, or it may have a built-in memory controller. Okay. So this is basically the system we have. Now, different parts of the system run on different voltages. And this will depend on the generation of RAM, the type of BIOS, the type of GPU, and various things. But basically, the BIOS will either run on 3.3 or 1.8 volts. Those are the two most common ones, at least. So the BIOS chip needs either a 3.3 or a 1.8 volt supply. So generally speaking, on our graphics card, we'll have a 1.8 volt. Other parts of the logic circuitry, there's logic circuitry on here as well, may require that voltage to run. So either that or the 3.3 is going into your BIOS. Okay. The PCIe Express, this is the communication with the motherboard. This runs on 0.9 volts, what is generally called PEX voltage. So we need a 0.9 volt supply coming in here. These are power supplies, okay? The 3.3 is used for various logic circuitry, or it may be used to derive some of the other voltages. We'll also find we have a 5 volt supply on our board, usually. I mean, you may find some graphics cards that don't have all of these voltages, but these are very commonly present. The RAM, well, depends on what type of RAM, but on modern graphics cards, the RAM runs at 1.35 volts. So we'll have a 1.35 volt supply coming into the RAM. The memory controller built into the GPU, because it's talking to the RAM, the supply voltage is probably the same or very close to the RAM voltage, but we have a supply to the memory controller if there's one built on the GPU. And this will probably be somewhere in the same region, about 1.35, okay? The HDMI, well, it could be running at 0.9 volts. On some graphics cards, it's running at 0.75 volts. So I have a 0.75 volt supply. And the GPU core itself runs on the lowest voltage, and this is generally running on 0.8, 0.9 volts, something like that. So the GPU actually has various power supplies. It has 0.9 volts, okay? Because it's talking to the RAM, it either has the same supply voltage as the RAM or something very close. Voltage mem control, okay? Because the GPU is talking to the HDMI, it also has to have that voltage supply, 0.75 in a lot of cases. Because the GPU is talking to the PCI Express, it also needs this supply. So you can see that the GPU needs several supplies. It needs one more. Because it's talking to the BIOS, it needs a supply at whatever voltage the BIOS is on. So 3.3 or 1.8. So you can see that this itself has at least 1, 2, 3, 4 voltages, maybe 5, yeah? The 5 volt feeds logic circuit on the graphics card. Sometimes you'll find the 7.5 volts. If you do find that, don't be surprised. As I mentioned, you won't always find all of these voltages on a graphics card. In particular, this one, the 0.75, is something you're going to find on ATI Radeon cards in particular. The voltage supply to the core, and for that matter the RAM, are generally controlled by the GPU. So the GPU itself, once it's running, can change the voltage supply to itself and to the RAM. So usually this one might be sort of like 0.9, maybe 0.8 something. But when the GPU starts running, particularly after the drivers are loaded, this will usually change. It'll go down to about 0.8 volts or 0.8 something volts. So don't be surprised to see that voltage change when the card boots up and the drivers load. And the same with the RAM. This will change, and you'll see that change a little bit as well. That's normal. So that's not like the thing's drawing more power so the voltage drops. At least not always, yeah. So just something to be aware of. And the other one is this PEX voltage. So smaller GPUs that run on 0.9 volts or higher, there's some that run on say 1 volt. If the core voltage that the GPU uses is higher than 0.9, it doesn't need a separate PEX supply. It only really needs this when the core itself is running at a lower voltage than that. Yeah, so don't be surprised, especially on smaller graphics cards, not to find there's a PEX rail. But if you do find there isn't a PEX rail, I'm sure you will find that the core is 0.9 or higher. So those are the voltages that we have on the board. Now, it's quite easy to see where these are coming from without even powering the board up. And we can measure the resistance on all of these voltage rails, and that will tell us a lot about the state of the graphics card before we even try to apply any power to it. So let's have a look on ours and see what we can find. Again, there's no exact rules about what these resistances should read. They will vary from graphics card to graphics card. Yes, it helps if you have a known good one you can compare with, but even if you don't, you can usually figure out if there's a problem. So the place to look for these voltages are on these coils. You can see these coils here. That's also a coil. That's also a coil, a smaller one. There's one there as well. There's one here. Okay. And if we look on the other side, there aren't any coils, but we have something that looks a bit like a MOSFET here. And this may well be a voltage regulator. So let's have a look. Well, that's marked 78M05. That's actually a 5-volt regulator. I know the part number, but you could go look for the data sheet for that and you'll soon find out what it is. So that we know that's your 5-volt rail. So let's look at this one first. So this will be powered in from the 12 volts. It needs to be running from a higher voltage, and the only higher voltage really is the 12. So that comes in on the fingers here. Yeah, that goes to our regulator. This is ground. So just go to ground. I'm on ground, and this is the out. And we'd expect this to be quite a high resistance. I mean, that's just reading very high. I was on continuity. Let's go to here. Yeah, I mean, that's like 5 kilo ohms. It's quite a high resistance, so that is okay. We also know we have a connection from the input to the 12 volts coming in, so we know that's okay. Sometimes there will be a fuse. Let's have a look. Well, in fact, this is a fuse marked F100, so that should be checked as well. Probably comes from the 12, you would assume. Yeah, reading 0 ohms. The fuse should read 0 or close to it, yeah. I mean, my meter doesn't zero properly. If I go short, you see it reads the same 0.4, okay? While we're on here, let's look for any more fuses. If there are any, they're going to be up here. Yeah, there's one there. And there's another coil, by the way. That reads 0, so we know the fuse is intact, so that's another good one. That will come from the 12 volts. Yeah, which is here, okay? How about these coils? Well, first off, this one and this one, because they buy the fuse and they buy here, are probably actually just filters. The way to normally tell is if there are any MOSFETs by them. Well, this has MOSFETs by it, so actually this probably isn't a filter. That one probably is a filter. We can check this. Go for the most obvious place from the fuse. Does it go to this coil? Yes, it goes to the coil. So we can say that's just a filter on. That's just the 12 volt rail coming in through the coil. Okay, the 12 volt will go to the various voltage regulators after that. So we have a coil here. This is by some MOSFETs. I don't know which controller it is. It's quite a big coil. It wouldn't surprise me if this is the memory controller or the RAM. Let's have a look. If it's RAM, you'd expect this to read anywhere from about 40 ohms up to about 140, 33. That could well be the RAM. I mean, that's not unusual. Samsung RAM tends to read lower than others. This is IFPUDEUV, but never mind. So certainly not short. That's probably RAM. How many more coils can we see? Well, there's one here. This is down near the PCIe, so this is probably PEX. And this will probably read somewhere about 20 ohms. Yeah, 15.7. Okay. There's another small one here. This might be the 1.8. Again, I don't actually know if it is, and because it's a small coil, I expect it to have quite high resistance. Yeah, 2.7k, something like that. We know we have 3.3 coming in. We know the 5 volts on the back, so that's probably the 1.8, but we'll measure them in part 2. At the moment, we're just looking at resistances. Now, this one is different to these 4, okay? These 4 are probably all connected together and they're driving the GPU, and you expect this to be a very low resistance. It's saying 0.8 of an ohm, okay? If we short the thing together, 0.4. So it reads about 0.4, 0.8, 0.8. 0.8. That is not a short circuit. Modern GPUs, you can expect them to read 0.4 of an ohm, 0.3, 0.2. That's quite normal. If you read them on diode mode or continuity, they will just read like a short. Yeah, you have to use resistance range. and just expect a low resistance. Yeah. So that is actually, I'm sure, okay. We can compare with the other one. So if this is RAM and these are for the GPU, and we've kind of said, well, probably 1.8 and 0.9. This is probably the memory controller. Let's have a look at it. This one has actually got no legs on this side. It's going through the board. So it's not a surface mount one, it's there. What's this one read? About 17, okay. This one's 17 and the one was 33. This is probably the memory controller. The only way to find out either A is to see if you can find a diagram that shows you or a schematic, but the best bet is just to measure the voltages. But as things stand, that looks pretty much okay. And let's compare it with the other one. What you're really looking for here is short circuits. That's the thing you should worry about. So again, fuse. Really short, comes through to here, coil's okay. This one we thought was the RAM. Yeah, 33, same as the other one. This one we thought was probably PEX, about 20 or something. Let's look at the other one compared with that. 15. So this actually reads a little bit lower on PEX than the other one. So that is a difference that is worth keeping in mind. We definitely have a difference there. I mean, that is like 25% lower. But this voltage rail, PEX, the only place it goes to is the GPU. And it powers the part of the GPU that is talking to the PCI. We notice ourselves, apart from some capacitors on the other side, it doesn't really go anywhere else. So if we have a problem with this voltage rail, the chances are it's a faulty GPU. I say chances are, it's worth investigating. This one, a small one, made about into the kilo ohms, yeah, 2.58, fine, it's quite high. These four were all core, and it was reading 0.8. Well, this reads about the same, 0.9, 0.9, 0.9, 0.9. This we thought was memory controller or RAM, one or the other, and it was reading about 13, was it something like that? Have a look. That reads 20 on this one. Go back to the other one. $17. So we can see there are two differences, but both these supply rails go into the GPU. If it tells anything, it's possible these have GPU problems different on the two. Okay, if you want to know which one goes to the RAM, by the way, the easiest way to find out is to go from the supply and look for capacitors right by the RAM chips. Okay, if you can see any and we can find the voltage down here right by the RAM chips, then that is probably what it's applying. Let's have a look. Actually, we can get on this side of this one. Yeah, 33. So you can see where the RAM chips are. Let's look for some capacitors. Okay, that's some capacitors here. So from the supply rail, yeah, look, it goes to these capacitors here under the RAM. Yeah, 33, 0. So we can say pretty confidently that is the RAM supply. And this one is the memory controller. And again, that one only really supplies the GPU. Let's have a look at the other card. Looks different, but we got pretty much the same thing. Something that looks like a voltage regulator there. Yeah, 78M05 again, so that's your 5 volt. You know straight away. So now we need to find everything else. Well, these 5 all the same are probably on the V core. That's what draws the most power. So you'll often find 2, 4, 8 altogether, 5 on this one. We have one there that's different. Okay, we have another one here which is different. I don't see one down by the PCIe connector on this, but there will be a PEX supply somewhere. Look on the other side. Oh, there's one there on the other side in that general area. So let's have a look. So this one first, if it's PEX, maybe about 20. Now that's 122, so it's quite a bit higher. I wouldn't worry about it particularly, but it's higher. Fuse, as we saw on the other one, read 0, comes from the 12 volt and will go to the 5 volt regulator. Yeah, you can see that, can't you? Okay. Fuse is okay. Goes to the 5 volt. Doesn't have to do, but that was a good guess. Output of the 5 volt. Yeah, kilo ohms, that's fine. We have a supply up here on the coil. That reads high. No, I've got it now. That reads about 40 ohms. 39, 40, yeah, 40 ohms. Could be RAM again, could be memory controller. Let's have a look on the other side. This might be RAM. 22, okay. We can do the same trick and figure out which one goes to the RAM. This will be the V core. Do they all read the same? Well, that reads 13. This reads 2.2. So this, the 2 point something is the core, always the lowest resistance. Okay. 2.2, 2.2, 2.2. So there are actually 4 phases on the core supply. This one is actually something different. 13.2, that may well be PEX. And this one is something different. 22, quite possibly memory controller. We have a few more coils over here. The one on the back that read 122, wouldn't be surprised that's the 1.8. But again, we have to measure voltages. At the moment, we can just get a general layout of what we've got. And this will vary from graphics card to graphics card, but you're looking for the same sort of things. So these here are probably filters. The reason I say that is because there's none of these driver chips or these MOSFETs next to them, okay? If they're filters, they're probably on the voltage rail coming in, which I think on here is down under here. Doesn't go to that one. Yeah, that goes to that one. Does the other pin for me go to this one? Let's have a look. This one, I wouldn't be surprised if it goes to the 12 volts coming in down here. Yeah, good guess or experience. What do you think? This one probably comes from up here again somewhere. Yeah, from there. And then this one also from there. So these are just filters on the input. Here are the fuses, like. Again, we can check the fuses. Okay. Okay. So I hope you can see how we can do these quick checks, and I can do this on any graphics card. I've never seen it before, doesn't matter. There's something else that looks like it might be a fuse there, but it could just be a low value resistor. NF, yeah. Worth checking just to see what this thing is. Reads low resistance. I'd expect it to read low. I don't know exactly what it is, but I'd expect something like that to read a low resistance, which it does, okay. And that's the end of part 2. So let's have a quick recap of what we've learned in this part. Firstly, we've done some more visual inspection. we've got an idea of what to look for that will indicate that the RAM has been working very hard on the graphics card. Quite likely it was used as a mining card. It's been running for many hours, and that's usually visibly obvious. Same with the GPU. We've looked at GPUs. We know now what to look for on the GPU itself. Quick visual check, and this will generally tell you if somebody has fried this thing with a heat gun, basically. Some amateurs tried to fix this and just made it worse, usually without making obvious checks before they fried it, but we won't go into that one. Yeah, okay. Then we had a look to see, and you should now know how to identify the voltage rails on any graphics card, whether you've seen it or not. Have a very good idea of what voltage rails you're going to have and what sort of resistances you're likely to see on those voltage rails. So we've done all that in this part. Part 3 coming very soon. We're going to go a little bit further in depth now with these resistance measurements. So we're going to draw this out on paper in the next part and have a look where we are likely to see short circuits, where the circuit is likely to fail, and that will give us a very good indication of what is wrong with our graphics card. So I hope you enjoyed that, and I look forward to seeing you all soon on the next part. Ciao for now, guys.